just wanted to clarify, is it just going to be chapter 1 material, or is it going to be all 3 chapters?
Chapter 1.
Okay.
Yeah. I like it. Okay, all right. So we're about to get into various graphical and visual displays of data, and then it's going to lead into more computational analysis of data. So the very first thing we do, this chapter is all about what's called descriptive statistics. You're going to describe a sample visually, computationally. So I can make a bar chart. If I say that, do you guys understand what that is? Bar chart. So it's not a chart of your favorite bars. All right. Something like this. And we're trying to get that up there, but so you'll see, for example, I don't have scale, so that's bad. You have to have a scale here. Because you will see, trust me, on certain news channels, you will see graphs. Same information, but here's men, here's women. But their scale starts at like 50,000 or something. I want you to really understand. And that's going to always diminish differences if you don't start at 0. You guys with me? Just one little stupid thing that they get away with because people don't even think to look for it. Like, look at the picture. Look at the actual picture. Right? You guys kind of with me?
Yeah.
This has nothing to do with ideology. This is just data. Ideology is what changes things, that tries to manipulate what people see. So all I'm saying is anything you look at that wants to be evidence for something, you've got to make sure it's represented correctly. Okay? You guys with me a little bit? Okay. I'm desperately trying to have my own ideology come in, but maybe it's too late for that already. I don't know. So one of the most... I wanted to finish this up. So this chapter is all about descriptive statistics. So visual stuff, calculating mean, and something called median, and so forth. All these little things. These are describing my sample. Then we're going to have what's called inferential statistics, which is where I take sample information and try to infer something about an entire population. And that's where that plus or minus 4% kind of comes in. We're trying to infer something about how everybody's going to vote based on a group of people I talk to. I like it. I like it. Oh, let me see. I don't know if red's the best. It's better than green, though, right? Weehaw! There you go. All right. So if I have some data, so say I've got some data. Let's say this is ages of people. Yeah, okay. Okay, all right, so everybody take a second. Unfortunately, a big part of this class is going to be lists of data. So, you ever heard of those jobs like over the summer make so much money per week? Most of them are data entry jobs where you just need somebody entering data, enter data, go insane, right? A little bit of a shining moment. All work and no play. So the very first way we want to represent data to somebody rather than just giving them a list. A list is nice, but it doesn't give us any impression of what's going on with the data. So one of the most basic ways I can give a visual of the data is something that's called a Stemandleaf plot. I think the book just calls it stem plot, which is really less interesting. What do you do with a stem and leaf? So how does a tree look? It's got a stem, and then it's got multiple leaves coming off of that one stem. Are you with me? My stems. So the stem is going to be the part that's kind of repeated. So do you see how there's several that are in the teens, right? So I'm going to have a 1 stem, a 2 stem, a 3 stem, a 4, and a 5. Get out of there. Is everybody with me so far? If I didn't have anybody that was 40, I should have left somebody out. I would still put a 4 there. It would just end up empty. It's like a stem with no leaves. You guys with me? So don't skip things. Don't skip from 2 to 4. That's being dishonest. You got to show empty stems. Now just fill in the leaves. What comes out for 1? 4, 6, 9. What comes out for 2? Careful now. You represent repeats also. Is this the same person? No, it's 2 different people. So if you only write one of them, you somehow merge them, right? They fusion. No. They fuse correctly. They're strong. And then what comes up to 3? And then 42 is the right answer for everything. And then 50, not good. All right, let me stop right there. Just appreciate this for right now, that this is that easy. Will it always be exactly that easy? No. The idea doesn't change, though. Somebody cool with this so far? You guys see that? So let me add one more thing. So what if I had a 71-year-old? What would you put next here? Yes. So easily excited. Yes. So visually, look what this does for me. Watch. Huh. Most of the people are aged in their 30s, right? It's not as quickly identifiable if you just look at the numbers. Now, if you stare at them and start to think about it, you can see it. But if I give somebody this, they see all the data, and they can see a visual distribution of the data. Can somebody identify an outlier? Outlier. Is there an outlier in this data? I kind of pointed to it. 71 is definitely an outlier, right? Why is that an outlier? It kind of doesn't follow this pattern of sticking close to 20s and 30s. It's way the hell up here. It's very far away from the next thing down. I like it. So there's several different ways right now to subjectively identify an outlier. We're going to come up with objective ways. Everybody cool with the difference between subjective, objective? Subjective is kind of like opinion. Objective is based on algorithms, right? So later we're going to develop a real good way to figure out outliers. Right now, I mean, 71's a freaking outlier. It is. It's just far away. You guys with me? A little bit? Now, this is not complete right now. I have to give somebody a key. You don't give me a key on this kind of problem, you're going to lose points. You just give me one example so I know how to read this. Because they're not going to see this data, whoever you show this to, they're only going to see this. So I want to tell them that 1/4 means 14. You with me? Yes? Sure. Yeah, as long as you show me that equality, that 14 is represented by 1/4. I like it. And then I can read the whole thing, right? So then I know that 3/1 means 31. Now stay with. That's done. That's done. I'm gonna go change something. Yes. Say again. Oh, yeah, you could just put it up here. I don't worry too much on this one about titles, but yeah, I like it. If you weren't actually giving somebody this, you would want to put up their ages of whatever this was. I didn't get that specific. Now watch, yes?
So do you want us to put like just the 1/4, or do you want us to go on to 7? Or will you get the...
Oh, I see. Do you see how if you do all of them, that eliminates the real utility of this? Then you're basically giving them all the numbers. Why would you do all this shit then, right?
So keep the keys.
It's sort of like on a map. You have one scale. It doesn't say, okay, from Austin to here, it's this far, and from this to this. It kind of eliminates the whole reason for the map. I just need one scale, and then I can use it everywhere. I need one idea how to read it, and then I know how to read all of them. So let me show you this. Let me make this. I don't know how you want to do this in your notes, but oh well. let's say this wasn't ages, this was weights of perfume, right? And it was 1.4, 1.6, 1.9. Okay, Jack, we get the idea. Does everybody see the difference now? This does not change. What changes? Yeah, the key now better look like that. Do you guys see that? Do you guys see it? So you can identify your stems. You can identify through your key where the decimal place is. Right? If I had somebody with me on this, you guys with me? No, what's up, Jack? You alright? So everybody realize that in this case now the stems are the whole number piece and the leaves are the decimal piece. This doesn't change. I identify what these mean through the key. You don't have to put point. In fact, that's missing the whole point of this. You don't have to do that because you can identify it in the key. Sorry for the pun. Yes?
Wait, is that?
Sorry.
Just a quick question. So, when you have, I feel like you can write a key easily if all of the numbers look similar format, but what if they're like 14.5 and then all the rest look like that? Like, how do you find a...
Oh, all right, let me say this. Not every data set will be easily representable by this, and you've identified one possibility. In that case, it would be really weird. You might even want to, if there's just one data point that doesn't follow a pattern, you're actually allowed to kind of like identify it and then have a pattern for everybody else. If there's just one data point, but otherwise you don't represent it using this. So I want you to really realize, I'm not saying every set of samples I could use this for. I'm saying this is one way we could possibly use to give somebody a quick visual. Will it work for everything? Oh, hell no, right? Like, you guys, we're not going to develop pie charts, but you guys have all seen pie charts. I don't know why I'm calling you galls. You galls. So for data that would have a ton, this kind of data, no, don't do that, right? Where it's like, it's so little change from one to the next, and there's gonna be like all the way around. Don't use a freaking pie graph for that data. You with me? There's certain data that won't fit into a format. But there's also a ton of data that will fit into this format. I like it. Now obviously data that doesn't have repeats really doesn't work with, it's no, why would you do this format if there's no repeated thing to be a stem? I like it. What about if I had data like this? How do you think I could represent that stem and leaf? What would my stems be? What do you think? Okay, I like it. So 1, 2, 3. See if you guys can get this. I would do this. What would my key look like? Yeah, see? Do you start to see some of the flexibility you have? You capture what the pattern is. There's a problem in the homework. I think I assigned this to you guys, where they say round the data to the tens place. So like, you're gonna round it to 152, 72, 82, 90. So when you make your stem and leaf, don't put freaking 50, 70, 80. You're just taking up extra space. You're wasting graphite, right? Just go ahead and capture it in the key. Do you guys see that? The key is what gives you flexibility here. You don't write a key, you lose some points. Because then I know how to read your shit. You like it? Don't say, well, you know, you're the teacher. No, I'm pretending like I don't know shit when I create that. You gotta tell me how to read this thing. You don't like it? It's not hard for me to understand. Alright. Because I don't know shit. Okay. What was next? There's several ones in section 2, one we're not going to do. Line graphs. The bar graphs I'm not going to really pay much attention to yet. Okay, 11. By the way, we are coming back to that frequency stuff in a minute, okay? They put this next thing in section 1.3, frequency distributions. I really wish they hadn't, but oh well, they did. Is everybody with me on this? So far, this is like, yes, please. Okay. Should. So now we're going to get to the real heart of the beginning of chapter 2 here. It's called histograms. So we start with frequency distributions, relative frequency distributions, and that leads to histograms. Oh my God. So I'm going to try to identify the part of this that section 1.3 wants you to do. And all that section 2.2 does is adds a few more things on top. So say it. Yeah, relative frequency distributions. Yeah, I set up a word and then I don't write the whole thing. Yeah, like it. I will say this. I know I write horribly. I know, but at least I can read it. I had a teacher that he would write and somebody would say, "What'd you write in the first thing?" And so you go, "Somebody remember what I wrote? I can't." It's like, oh my God, dude, you need to retire. Stop. So at least I can still read my own horrible hieroglyphics. All right, so here we go. I'm gonna give us some data. Oh shit. Let's say that this is, I don't know, golf scores. Why not? Or actually, let's do this. Let's be more interesting. Anybody not willing to tell me their age? That's too funny. All right. So I'm going to ask you guys what your age is. So let me see. What's your age? How old are you?
19.
19. Keep going. 20. Keep going. There we go. Keep going. Huh? 29? 21? You just added 8 years. 18. Loud and proud, everybody.
30.
30? 21?
20.
20? 19? 19? 21? 20? 22? What happened? I kind of, real quick, sorry. When I was 23, that was the time I forgot how old I was because 21's big. Why is 25 big?
Quarter of a century.
Huh? Quarter of a century, sure. Your insurance for cars goes way down. Because all of a sudden, mathematically, you suddenly learn how to drive on the morning of your 25th birthday. So when I was 23, I was like, how old am I again? Because there's no reason to know. So you shouldn't feel bad. 23, all right. 19? 42?
38.
38? 38?
23.
23? Jim Carrey would freak out. 19? 21? 21? 18? 20? You told me. 21? 19? 19? 27? 38? 22? 19? 18? 20? 17. Okay, now. Oh, let me up there. 46. Okay. So if anybody got you all beat. Been on the earth longer. Let's first make a stem and leaf, because a stem and leaf is actually a quick way to put something in order by hand. So what's my stems going to be?
1, 2, 1 and 4. 2, 3, 4.
Okay, good. All right. So then the ones, let's see, let's try to do this in order. So I think the lowest one is 18, right?
17.
17? Where'd you go, 17?
Second from
I'm lost.
Oh! Gosh, okay, 17. And then there's 1, 2, 18s, right?
No,
Another one? There, okay. Thank you. By the way, probably in the break I'll go get a bag of calculators. I'm going to show you how to have the calculator sort this. But I figure for this problem it's good for Stemandleaf practice. No more 18s, right? How many 19s we got? 1, 2, 3, 4, 5, 6, 7, 8. Yes? Put this 8 over here. 1, 2, 3, 4, 5, 6, 8, right? I forgot already how many there were. Were there 8?
Yeah.
Thank you. Is everybody with me? Some of you guys look confused. Nothing big is happening yet. All right, so that's in the teens, right? No drinking legally. 20s. Let's see. I got 3 20s, 4 20s, 5 20s,
6 20.
6 20s. Oh, this is a 22, I think, right? 5 20s. Almost was 4 20s, man. 5 20s. How many legals we got? We have 1, 2, 3, 4, 5. 21s, is that right? 6. Uh-oh. Or just at 21. Okay. 22. 1, 2, 2 22s. 23. 1, 2. I think that's it. I thought there was one more.
C3.
Oh, there. So 3 23s. 24 no. 25 no. 26 no. I think there's a 27. Is that it for the 20s? Yeah. Thank God. 30s. I got a 30. 38 and a 38. Good? Yes? Looks good, looks good. And then my 40s, 42 and 46. Yes? All right. Everybody with me? So if you had to do by hand a sort, Stemandleaf is not a bad way to do it because it kind of like categorizes things so you can sort within those categories. It makes it a little bit quicker. I am going to show you how the calculator will sort stuff for you. Is this complete yet? And it doesn't really matter. You can pick whatever you want to. 42 is 42. Just pick one and represent it. Represent. Real quick. Don't add this. If there was somebody in here who was 100, that would be kick-ass, but how would I represent that up here? See if you guys can do this correctly. Yes. So I'd have 5, 6, 7, 8, 9. They'd all be empty, and then there'd be a 10. If I put 1, 0, 0, what would that actually mean? I have 2 10-year-olds. This is one 100-year-old because it would follow this pattern. There is nobody 100 in here. Hopefully. Or else it's still coming back for the tour. I don't know. Like, come on. Sorry. Okay. All right. So I'm going to take this away because it's really messy. And here's my data here. Can somebody tell me, what's your gut tell you is the range of this data? Yeah, I'll tell you this, the range is a number. The range is a number.
It would be 46 minus 17.
Yes, I love it. So the range is the high minus the low. Yeah, it was, what was it, 40? It was me minus 17. So that is okay, I like it. So that's the range. The range is always high minus low. Now let me give you an idea of the goal of what we're about to do. We're about to try to create what's called a histogram. Thank God I do have another handout. So the way I try to do this is to lecture some and then shut the hell up for a bit. Because I know if you sit and listen to somebody, you're like, God damn. And you're like, yeah, Jeff. Yeah. All right. So here's what a histogram's shape should look like. It should look like, oh my God. I'm telling you, these are real rectangles. Like that. The heights might change, but that's a histogram. It's going to have a scale here. It's going to have a scale here. Actually, the scale should match up with these. So for example, let's say this is the frequency. Let's say 10, 20, 30, 40, 50. Can you guys all see that? I wasn't really planning on making it a specific example, and then I decided to do that. And let's say this is a number of weeks between jobs. And this is the how many people, right? So can somebody tell me roughly how many people were from 10 to 20 weeks without a job?
10.
Yeah, a little more than 10. I'd say like 13 maybe or 12. If I had a better, this is a crappy ass picture, but just an estimate. Are you guys, does everybody see that? Does everybody see that? So if you had if you had been off between you got off one job and then started the next job 17 weeks later, which bar would you be in? Yeah, the first bar. You guys with me? So there are about 13 people that were off work between 10 and 20 weeks. You guys with me? You guys can see that? Yes?
So is it the same thing as the bar graph?
Now here's the difference. I love that you said it because I forgot to say it. Histogram is for quantitative data. Bar graph is for qualitative data. So would you say this is a real scale? Like on this one, is women above men? Well, that could be a interesting discussion. Should men come first? Well, that's another, I don't know. That was inappropriately stated. But you guys see, this is truly numerical, so the scale does exist. A bar graph, do you see how there's a gap here? Because this doesn't mean that I'm missing anybody. Because this is definitely men, and then this is women, right? Or if I had car types, Ford, Hyundai, BMW, whatever. You guys with me? Histograms are for quantitative data, and they have to have no gaps unless there's something that has nobody in it. So like if I went to this, how many people were off work from 60 to 70 weeks? Nobody. So I love that question. Is that good? Bar graphs, qualitative data. That's a callback. What the shit's qualitative data? We don't know, Jeff. Qualitative data? What kind of data is that? Categorical. Quantitative data, histogram quantitative is truly, truly, truly numerical. I like it. You guys, was there a question? You guys all right? Okay. That is our goal right now, is to create this kind of picture. I like it. Maybe. Let me see, what was this? Give me 1 sec. Oh yeah, okay, good. Okay, that'll work out beautifully. So everybody with me? So I do like this kind of problem where I give you a completed one of these just to make sure you can read it. If you're able to read it, you might understand better what we do to create it. I like it. So I want each of these rectangles represents what's called a class. And it looks like the classes go 10 to 20, 20 to 30, 30 to 40, yes, right? So that was a choice somebody had to make. If I took the same exact data and went from 10 to 15, 15 to 20, I'd have a lot more rectangles and it would look different, wouldn't it? You guys semi with me? So I can increase the resolution if I need to by making more classes. Are you guys semi with me? If I wanted really low resolution, I make one class from 10 to 80. It would be this giant box. It's like, that didn't show me shit, right? Can't like it. Increase the resolution, make more and more rectangles, right? Get the 4K Ultra, whatever the shit. Okay, I like it. Maybe. Besides my little monochromatic one I used to have. All right. So I want my first step here is to create these classes. Can somebody tell me what was the absolute lowest data point that there could have been in this data? 10. Were there any zeros? No. What's the most it could possibly have been? 80. Could there have been any 80s? Could there have been like no 80s? Yes. Could there have been nothing but 73s here? Yes. We don't know where it was in 70 to 80, but I know there was roughly 30 between 70 and 80. Are you guys with me? Yes.
So is the class 10 to 20
Good.
to 30?
Yes.
Okay.
Kick ass. So we have to determine somehow how wide should our classes be for the data we've got. Okay, now here's the thing. Classes. We are going to use, oh my God, Jeff, what language is that? We are going to use ARG, yes. 5 to 10 classes. You use 4 classes, you're going to lose a lot of points because everything after that's going to be based on a wrong conceptual understanding. Less than 5 is not good enough resolution. More than 10 is getting too specific, giving everybody their own class almost. And it should kind of make sense. When you use 5, when you have a smaller sample size, and when you use 10, when you have a bigger sample size. There's an actual formula using logarithms. You guys know logarithms? We're not going to use it, okay? So just calm down. I don't really agree with it, to be honest. It's just fancy. It's got logs in there, like, well, that's nice. But you could just subjectively pick. Now, if you purposefully pick something to make your data look a certain way, that's crap. But if you just kind of arbitrarily pick something towards 5 because it's smaller, then you're not really trying to pull the wool over everybody's eyes. Right? It can still happen accidentally, but still. Maybe. So on a test, some of you guys could have different looking histograms based on how many classes you pick, which is really exciting for me to grade. I know, well, that's what I do to myself. So let's use 5 classes because it's a very small sample size, right?